Hi, I'm Axel Zuniga.
Hi, I'm Jasmine Muciño.
Hi, I'm Jose Luis,
Hi, I'm Mildred Ramirez.
and we are the team of 661 with Adriana Riola.
Let's start with projectile motion without air resistance. It is a variable described by a particle ejected in an angle, and the motion in x is going to be uniform rectilinear motion, and in y it's going to be accelerated uniform rectilinear motion, and acceleration is going to be determined by gravity.
On the other hand, we have the projectile motion with air resistance. When it's going in the x-axis, the range will be less due to the air resistance. And when it's going the projectile upwards, we have the air resistance force going downwards, and also we have the gravity. And when it's going downwards, the projectile, we have that the air resistance force will be going always opposite.
These equations are used to the movement without air resistance. These two from here are used to calculate the final velocity on the x-axis and on the y-axis. And these two from here are used to calculate the distance on the x-axis and the height of the y-axis. As we saw before, the acceleration on the x-axis is always the same, as while the acceleration on the y-axis is affected by the gravity.
And now we're going to explain the air resistance in projectile motion equations. Basically are these ones. The first one is the air resistance equation. That is basically the half of the drag coefficient multiplied by the area, multiplied by the density of the air that we're using in that moment. It depends on the height of the exercise, of the height, sorry, and multiplied by the square of the velocity on that side. Then, with the Newton's second law, we obtain these equations. That is, symmetry of forces in x is equal to the half of the coefficient of the drag by the density of the air by the cross-sectional area, and multiplied with the velocity in x. All of this is equal to mass times acceleration in x, and it's the same in the y-axis, that we only add this minus mg and the absolute value of the velocity y. And with acceleration, it's almost very similar. Acceleration is equal to the minus half of the coefficient by the density multiplied with the area and multiplied finally with the velocity over the mass of the body. And now we're going to explain basically the relationships between these variables and the projectile motion, how they affect the result that we are going to obtain in the path.
Velocity is going to be opposed by drag. That's why initial speed is going to affect the vector of velocity. Initial angle is going to determine the movement in y-axis. The greater the mass, less is going to be the difference, since mass is not contemplated in vacuum. And the greater the diameter, the movement in projectile motion is going to be less, since it's going to be in contact with more molecules.